Hey guys, today we're going to do a video just on general concepts in algebra, something that I see a lot with my students in grade 7, grade 8, grade 9, and even something that can go into high school in grade 10, 11. And it's just the idea of always, first of all, writing really organized solutions because you are building habits towards moving towards problems that are very, very complex, and you need to have your solutions well organized to be able to solve those kinds of problems. But also just the idea of always looking for inverse operations, because that's really what algebra is. It's simplifying down expression using inverse operations to manipulate equations, expressions, so that we find the solutions that we're looking for. So if we start with something relatively straightforward, something like 2x plus 3 is equal to 15, we have two operations that we need to undo in some sense, right? We have to undo the plus 3, and we need to undo the times 2 so that the x stands alone, right? And so the first thing we need to do is subtract 3 from both sides. And so we readily subtract 3 from both sides. The 3's cancel out on the left. And so we get 2x is equal to 15 minus 3, which is 12. And now we think, okay, how do we get rid of the times 2 in front of the x? Well, what's the inverse operation of multiplying by 2? Clearly it's dividing by 2, much like the inverse of adding 3 is subtracting 3. And so we'll divide by 2, always doing the same thing on both sides. The 2's cancel out, and we find our solution that x is equal to 6. Okay, straightforward enough. Now we move on to something where we have a variable term on both sides and a bit of fractions just to kind of mix things up. And so we do the same idea. However, now we have something to do first before we get into the inverse operations, right? We want to isolate the variable on one side, and so we want to move all of the terms that contain a variable on the same side. You can choose whichever side you prefer. I'm just going to move them onto the left side. And so again, if we want to move something on the left side, what we really want is to bring this over, and so we want it to no longer be on the right side. So for it to no longer be on the right side, we need to kind of cancel it out, and we do that by adding the inverse of negative 5x. And so the inverse of negative 5x is positive 5x, okay? And now again, the central idea of algebra is we always do the same thing on both sides, keep things equal. And so if we add 5x, we have to add 5x to the left side as well. Now, negative 5x plus 5x cancel out. And so we have 3x plus 5x, that becomes 8x minus 1/2 now is equal to simply 1/2. Okay, so right away our equation becomes much easier to solve. Now we're kind of back to step 1, where we simply have to cancel. We have to do the inverse operation of subtracting 1/2, and then we have to think of the inverse operation of multiplying by 8. So let's start off by doing the opposite, the inverse operation of subtracting 1/2, and that is clearly to add 1/2, always doing the same thing on both sides. And so the 1/2's cancel out, negative and positive quantities cancel out. And so we're left with 8x is equal to 1/2 plus 1/2. It gives us 1 whole, okay? And now we think, well, we want to end up with x by itself, not 8x. And so what is the inverse operation of multiplying by 8? Clearly dividing by 8, and so we divide both sides. The 8's cancel out nicely, and we find our solution that x is equal to 1/8, okay? For those of you that are studying conversions, remember, fractions really want the decimal. This can become a decimal by dividing using long division. 1 divided by 8, you can set that up as long division. 8 dividing into 1, we know the answer is going to be a decimal, and so we can put a few decimal places to give us room to work, and then we can kind of go through that process, and I assure you your decimal form comes out as 0.125, okay? Next, we have a level 3 question, something that might be something new for some of you guys. I assume you'd see this in around grade 10 or grade 11, depending on what courses you're choosing to take. But it's the idea that no matter how complicated our equations get, we can always use the idea of always looking for inverse operations to cancel stuff out. Because in the end, we always want to isolate our variable. We want to find the value of our variable. Now there are situations where we have to use more sophisticated methods, but when we're looking for a variable as we are in this kind of equation, it's always the idea of inverse operations, okay? So now we have a cube root of a function here. Now this entire thing is underneath the square root sign, okay? So we're not going to touch that right away. What we're going to do is we're going to isolate this piece by getting rid of the -2 that's on its same side, okay? So first off, we're going to start off the inverse operation of subtracting 2. Now, clearly that's adding 2. So let's do that for the very first line of work, okay? So adding 2 on both sides now brings us to the cube root of x, apologies, x squared plus 4 is now equal to 3 plus 2, bringing us to 5, okay? Now, that cube root is affecting all of the x squared plus 4 because x squared plus 4 is underneath its entire cube root symbol. And so now we want to get rid of that cube root because that's really what's getting in the way of allowing us to find out the value of x, right? And so the inverse operation of the cube root is raising to the power of 3, or cubing it, okay? So now we're going to raise all of this to the power of 3 so that the cube, appropriately enough, cancels out the cube root as such, and we always do the same thing on the other side, and so we're going to take the cube of 5 as well, okay? Now our cube root is completely gone, so all we have left is x squared plus 4, okay? A much easier expression to deal with. And on the right side we have 5 cubed. For those of you that are familiar, that has a value of 125. And so now we're almost back to a step 1 equation. We have a square, but that's not too difficult to deal with. First off, we want to isolate our variable, so we want to get rid of the plus 4, and so we again think inverse operation of adding 4 is subtracting 4, and we always do the same thing on both sides, and so if we subtract 4, that's going to cancel out the addition of 4, and so we finally have our x squared isolated on one side, and we have it being equal to 125 minus 4, which is 131. And then finally, something you would have been introduced to in around grade 8. We want to isolate the value of x, not just x squared, and so we want to think of the inverse operation of the square. And so that's clearly the square root. We always do the same thing on both sides, and so the square root and the square cancel out, and we get a value of x is equal to, now one thing when we take square roots or any even root, for those of you that have seen this already, we have to take the positive or the negative value, because when we square a number, whether it's positive or it's negative, once we square it, it becomes positive. And so the square root of 121 can either be positive 11 or it can be negative 11. And so we have to take both solutions into account. And since there are no restrictions on our domain or anything of the sort, this is our solution, okay? And so I hope this just kind of illuminates the concept of always looking for inverse operations to cancel stuff out. No matter how complicated an equation might look at first glance, if you just take it step by step and you go through the process of chipping away one inverse operation at a time, before you know it, you typically end up with something that is far more manageable than you might have looked at the start, okay? So I hope this helps. Again, if you guys have any questions, comments, requests for future videos, please leave a comment, and thanks for watching.